So your unit 4.1 to 4.4, it's going to be 50 points. It's considered a quiz. It doesn't cover all of Unit 4, only the sections that we just done, 4.1 to 4.4. The first three types of questions, the first 4 types of questions, so part 1, asks, is the given a linear function? So this is similar to the study guide that you guys had. I'm just going to give you examples and definitions of how you could tell for sure something is linear. Something is linear, a function is linear, if you can write it in either standard form, which is ax plus by is equal to C form, or if you can write it in standard form, which would be y equals mx plus b. All right? The other way of looking at it is, and this wasn't really discussed much, but I did mention it a little bit, if the largest exponent is a 1, so if the largest exponent is a 1, which in this case, ax to the 1, it's understood, it's to the power of 1, x to the 1, y to the 1. And there's no variable in the denominator. So I'm going to give you an example or several examples of linear functions. First of all, if you have something that looks like this, 5x plus 2y equals 7, that is linear. If you have something that looks y equals negative 1/3 x minus 2, that is linear. If I have something that looks like y equals x plus 5 divided, let's say x plus 15, divided by 5, that is also linear. Because if you go back into when we learned how to separate this at the very beginning of the year, that's the same thing as x over 5, which is really 1/5 x plus 3. There's an x, there's a y, highest exponent is 1. It is considered linear.
But why 3?
Because if we simplified x over 5, you get 1x over 5, and 15 over 5 is 3. Okay? You're not going to have to break it down from this to this, but you're going to need to know. All of these are linear because of the fact that the highest exponent is 1. Notice here, the exponent of x is understood to be 1. The exponent of y is 1. Y, x, all 1. All of them are 1s. And there's no variables in the denominator. So those are all linear. So these are, yes, linear. Examples of no to linears would be something like a quadratic. 2x squared minus 3 equals y. Power of 2 makes a u. It's not a line. Highest exponent is 2. Or x squared minus 5 or plus 5 divided by 7 is equal to y. That's a quadratic. Y equals the absolute value of x minus 3. That's an absolute value. Those are not linear. So, okay. You're also going to be given graphs, and you're going to be asked, is the graph linear? So I think those are actually a little bit more straightforward because you can look at it and see if it makes a line. So if I was to give you something like this,
Is it still the same?
it's still the same part of the test. Yeah, there's 4 questions like this. So some of them will look like these and some of them will look like this. But altogether, this part has 4 questions on it. So let me write that. There's 4 questions. So if I drew this, is this linear?
No.
No, it's a quadratic. What about the blue? Is this linear?
Yes.
Yes, it is a linear function. Correct? Is this a linear function?
Yeah.
But it's not a function.
Say it again, Rose.
It's a linear, but it's not.
Exactly. It is linear, it's a line, but it's not a function because if you think about it, the vertical line test makes him fail it. So, vertical lines, yeah, they're lines by definition, but they're not functions. Then you're going to have questions where it's going to give you a table of values and it's going to ask you if it's linear.
Still the same part.
Yep, still the same part. If I gave you a table of values, x, y, here's a table. If I asked you, is this a linear function? At first you can look at it and go, well, I know it's definitely a function because the domains do not repeat. All the x's are different, correct? So it's a function. Now the question is it linear?
Yes.
In order for you to check to see if it's linear, you have to remember that there has to be a constant rate of change. And the constant rate of change is known as change of y over change of x. Every change of y over change of x must be constant. Let's take the first one. From -4 to -5, that change of y was down by 1. From -3 to -2, the change of x was that you went up by 1. Go to the next one. From -5 to -6, I went down 1. -2 to -1, I went up 1. So far, so good. -6 to -7, I went down 1. -1 to 0, I went up 1. And lastly, from -7 to -8, I went down 1. And from 0 to 1, I went up 1. The rate of change is all equal. So, yes, this is linear. If one of those rates was different, no, it would not be linear. So, as it is right now, it is linear. But let me show you what would happen if it looked like this. Okay, so as it is right now, it's linear. If I decided to change this let's just say -4, okay? I know it's out of order right now, but let's make believe that it was in order. If I wrote it in order and I made it -4, -3, -2, -0, and 1, okay? So I am rewriting a problem for the sake of showing you how to tell if it's not linear. So -4 was -6, -3 was -4. I'm just rewriting it. In order to check to see if this is linear, okay, so I'm going to move this out of the way so it doesn't distract us. I have to check to see if the change of x over change of y is consistent. From here to here, I went up by 2 and up by 1. That's my first change of y over change of x. The next change of y over change of x, I went down by 1, up by 1. I'm already not linear because it's different. So this is not linear. Again, it may be a function, but it's not linear because in order to be linear, you have to have a constant rate of change. The next part of the test is going to ask you about x and y intercepts. Find the x and y intercepts. So before we even begin to look at what it's going to look like, what do we already know about x intercepts?
The y value.
Correct. Nice. The x intercepts are the values of x when y is equal to 0. That's 1. The y-intercept is the value of y when x is equal to 0. If you forgot the reason why, it's because if I cross the x-axis here, I am an x-intercept. All of those points are x-intercepts. And every single value of y is equal to 0. This could be 1, 0. This is 2, 0, 3, 0. The ones to the left are negative 1, 0, negative 2, 0, and so on. The x value is a number, and the y value is equal to 0. Similarly with y-intercepts, if you cross the y-axis, that means you are going over 0, and you're just moving vertically. 0, 1, 0, 2, 0, 3. All of your x values are 0. So x-intercept is the value of x when y is 0. Y-intercept is the value of y when x is 0. So if I gave you a graph that looked like this, and I asked you, find the x and y intercepts, you would say, oh, the x-intercept is right there, correct? He's located at 3, 0. So the x-intercept is 3, 0. They didn't say what's the value of x, they asked what the x-intercept was. Intercept is a point. The y-intercept is right there. 1, 2, 3, 4, 5. I went over 0, up 5. This is my y-intercept. You're also going to have questions like where it asks you to find the x and y intercepts and then graph the line, and I give you an equation like negative 5y plus 3x is equal to 15. If you're asked to find the x and y intercept given an equation, you have to go back to these facts. Your x-intercept is the value of x when y is 0. Your y is the value of y when x is 0. So you're just simply going to go, okay, my x-intercept is going to be when I plug 0 in for y. So negative 5 times 0 plus 3x is equal to 15. Negative 5 times 0 is 0, just goes away. 3x is 15, divide by 3. You get x is equal to 5. So that means that the x-intercept as a point is what? 5, 0. That's your x-intercept. Similarly, when they're asking me, the second part of the question is the y-intercept. So your y-intercept is the value of y when x is 0. So pay close attention to the format this is written in. This is linear, but it's written out of order. So don't immediately think that this is an x. Look, you got to look at it and make sure you see that's y, and that's x. If I wrote it in standard form, it would be 3x minus 5y equals 15. So when you plug in your values, make sure you're plugging it into the correct variable. So the y-intercept is the value of y when x is 0. So negative 5y plus 3 times 0 is equal to 15. 3 times 0 is 0. Negative 5y is equal to 15. I divide by negative 5, and I get that y is equal to negative 3. That means that my y value on my point is negative 3 when the x is 0. It was asking beyond just the x and y intercept. It was asking for you to graph the line. So now, in order to graph this, it hopefully will be pretty straightforward. You already know that your x-intercept is 5. You already know that the y-intercept is -3. Connect the dots, and now you have your graphed line. So this question, again, it was asking for the x and y-intercepts and to graph the line. Now, by looking at this, is the slope positive or negative?
Positive.
Positive. Remember, when you're asking yourself whether it's positive or negative, look at the leftmost point. Go up from left to right. So it's positive. In this case, positive.
So
If it had gone like this, the blue line is negative because it's going down from left to right.
And then this is 0.
Right. So then, just as a quick aside, vertical line has undefined slope. Horizontal line has a slope of 0. Okay? Which we will cover in a minute. Okay. There's the next one. The third part, which covers section 4.3, so as you could tell, section 1 is 4.1, section 2 is 4.2, section 3 is 4.3. This one is going to ask you, this was rate of change, which remember we know that the rate of change is synonymous with what word? Constant rate of change, which is slope. All right? If I gave you a table of values, so this table is going to show the average amount of pounds that we increase when we're working out, or in other words, the amount of pounds we lift. We're weightlifters. The amount of pounds lifted as days go by. So we get stronger and stronger. So day 1, we lifted 10 pounds. Day 2, we lifted 12 pounds. Day 3, we felt really good and we lifted 15. Day 4, we were even stronger and we lifted 20. The question is going to ask you, find the rate of change for each time period. During which time period was the rate of change, or did the amount of weights we lifted increase at the fastest rate? So it wants us to find the rate of change for each time period. So you're going to have to find the rate of change between this one to that one, the second and the third and the fourth. So there's 3 rates of change, right? And rate of change is change of y over change of x. So the first rate of change was I went up 2 over 1. That means that I increased 2 pounds in the first day. The second day, I increased 3 pounds when I went up by another day. And the third, I increased 5 pounds in that day. So those are the 3 rates of change. Which one was the fastest rate?
The 5.
The last one, right? So the fastest rate in which time period?
4.
Between
Day 3.
or from day 3 to day 4.
That's a constant rate, right?
From day 3 to 4, you increased at the fastest rate.
So weird.
Next,
Wait, are we having this tomorrow?
looking at this, I want to know the slope of this line. Well, just by looking at it, is it a positive or a negative slope?
Positive.
Positive. Good. So you already know it's positive. Now, when you're finding the slope of the line, you need to remember that slope is change of y over change of x, also known as rise over run. I am going to see how much I changed from -5 on the y to 3. You went up 1, 2, 3, 4, 5, 6, 7, 8. So you went up 8. and you ran to the right, you went from -4 to 1. You went over 1, 2, 3, 4, 5 to the right. So the slope of this line is 8/5.
Well, I'm confused.
So let's say that it looked like this, okay? And now I'm going to actually change these values. Just by looking at it, hopefully you can see that this one is going down from left to right.
So it's negative.
So you know it's negative, just to give you guys an idea.
Both?
And in this case, I'm going to go down 1, 2, 3, 4, 5. So I'm going down 5. That's -5. And I'm going to go over 1, 2, 3, 4, 5, 6, 7, 8 to the right. So the slope of that line would be -5/8. Okay, so let me erase this so you could see it again. I switched the line just so that you could see what it would look like if it was negative. From here, I went down 1, 2, 3, 4, 5. So I went down 5 units. 1, 2, 3, 4, 5. Down 5. And I went over from here 1, 2, 3, 4, 5, 6, 7, 8.
Can you go over that way?
We always run to the right because you go from left to right. You go down and over or up and over, but you always run to the right. The last section, which is section 4, is the slope formula. It is one of the most important things in this unit that you remember that when you're given 2 points, you can figure out the slope because of the formula. And what was that formula? What's the slope formula?
Delta y over delta x.
It is change of y over change of x, but what's the formula?
Oh, y2 plus
Minus y1 over x2 minus x1. When you guys get stuck, you were all correct when you said delta y over delta x, change of y over change of x. When I calculate change, I want to know what the difference is. If I want to know how much I changed from 5'5" to 5'10", I want to know what the difference was in that, right? So change is the difference. That's the reason why change of y is the y subtracted and change of x is the x subtracted. So if I gave you 2 points, find the slope given 5, -3, and -3, -7, you should immediately look at it and go, oh, I have 2 points. Oh, I can find the slope. That means my first point is this one. My second point is this one. When I go to substitute it into the formula, I just have to be careful about my minuses. y2 minus y1, which is -3, correct, it becomes a positive, over x2, which is -3, minus x1, which is +5. But exactly like Sean said, these 2 minuses become a positive. -7 plus 3 is -4. -3 minus 5 is -8. What does that simplify to?
2.
Positive 1/2. A negative divided by a negative is a positive, and 4/8 is just 1/2. That's the slope I want to see.